Hey there, and welcome to Data Platform Summit. I'm Monica Rathbun, and this is Mastering Tempdb. Thanks for joining me. Last year, I was able to come out to India to give my presentation in person, but unfortunately, this time, for all of us, it's virtual. But I thank you so much for joining me for this session. I'm a consultant for Denny Cherry and Associates. I've been doing SQL Server for about 20 years now, specializing in performance tuning. I absolutely love performance tuning, and Tempdb is a big part of that. I'm a Microsoft MVP, and I blog avidly at SQLespresso.com. Feel free to hit me up at any point in time after this session on LinkedIn or on Twitter at SQL Espresso. Let's get started. Now, our agenda here. It's important to lay a foundation, first of all, of understanding what Tempdb is and how it's used. Then we're going to talk about how we can properly configure it to make sure we reduce contention. We'll go into what exactly contention is and the 3 different types of contention with Tempdb that you need to be aware of. We'll dig inside and look at long-running transactions and how that can affect us, and how to deal with an overgrowth of Tempdb scenario where we run out of disk space, and how to solve that problem effectively, which is something we've all run into over time. We'll talk about spills to Tempdb, and then we'll talk about 2 things that 2017 and 2019 SQL versions bring us to help make Tempdb even better. The last thing we're going to get into is always-on availability groups. Those things actually use, the read-only replicas actually use Tempdb, and we need to kind of get a grasp on exactly how it does and uses that, and how it can affect our primary. So when time allows, we're going to 2 demos, and I'll show you the 2 things that came with 2017 and 2019 versions of SQL Server that I'm very excited about. So let's get started. First, let's lay that foundation of understanding Tempdb. Most of you guys probably will know this already, but I think it's important to at least do a review, and maybe you can pick up on 1 or 2 things that you may not have known about. First, let's dive into what is Tempdb. It's a global resource used by everything inside SQL Server, whether it's done by the engine itself or user transactions or some things in the background that you might not know about that actually uses Tempdb. It's used by everyone, and it works in a round-robin fashion where it spreads the load throughout multiple files, and it reuses the resource over and over again at a really, really high concurrency where things are actually destroyed and created very, very fast. It's non-durable. Well, what does that mean? It means it actually gets recreated upon restart of your SQL services. It actually deletes all of the objects and creates them from scratch with an empty Tempdb. Now, you need to keep that in mind as we move forward, and we'll talk about just why. Tempdb is used by everything. Remember, it has very, 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 very high concurrency. We've got all these temp tables that are going on. We've got all these operations that are all happening really, really fast. So it needs to be set up and optimized on the fastest disk possible so we can get the greatest amount of throughput for all these transactions that need to happen. And we got to also keep in mind that things that don't fit into memory and that can't be done within memory sometimes has to go to disk, and that means it's going to Tempdb to actually use its resources to get things done. We'll see exactly how that works. SQL Server tries to make that as fast as possible, so it actually does some minimal logging. It logs things differently than what it does on a normal user database. So that way it can actually make things faster. You don't have to do that point-in-time recovery and all those types of things that are logged on other databases. Tempdb gets recreated, remember? So it can be minimally logged and logged differently than your other user databases. Really important things to note is, remember, you only have one Tempdb. Whether you're in the cloud in Azure or whether you are on-prem, you only have one. Treat it with care, set it up correctly. And remember, and I'll say this again many times as we go through here, things will disappear inside Tempdb. So please don't go create objects inside Tempdb that you expect to be there later. Don't use it as your scratch database, your dummy database, where you're doing some testing or some development or anything like that, because if those services restart, bam, those items are gone. You no longer have those objects. So please make sure your developers or whoever else is creating objects with inside Tempdb realizes that those things are going to disappear and you can't get them back. So keep that in mind. Now, sizing of Tempdb does matter. It matters because the amount of transactions that are happening in there and the amount of concurrency and contention that can occur inside your Tempdb. So it's important that we properly size Tempdb and we keep that sizing in line when we have multiple files. We're going to dive into that in just a minute. Now, we want to know exactly what uses Tempdb. We say it's a global resource and it's used by everything, but what exactly is going on and being handled with inside Tempdb? You have your temporary user objects, right? Those are the obvious. Those are your table variables. Those are your global and local table variables or temp tables. They're indexes, temporary indexes that might be happening, temporary store procedures, some table valued functions that may actually return information, or cursors could actually be using it as well. The engine uses Tempdb to actually do some things, and those are your internal objects that are related and created just by the database engine that you might not be aware of. We've got some work tables. If you ever notice inside your execution plans where you have some spools and sorts and maybe some temporary large objects that are created, those are all happening inside Tempdb. Now, we've got some work tables that actually do some things inside Tempdb. You've got your hash joins, some aggregations that might actually happen inside the work files. If you ever run set statistics IO and time on, you can see those work tables and work files that are created and rows and logical reads and stuff that happen within inside those. That's actually Tempdb. You can see your store procedures and your queries utilizing Tempdb work files by looking into that. Sorts. All of those indexes that are created or rebuilt with sort and Tempdb specified, yep, that actually does happen in Tempdb, which makes a lot of sense, right? But did you also know your group bys and your unions and your order bys all get done with inside Tempdb? So if you have a select statement that brings back millions of rows and then you do an order by, those millions of rows are resorted inside Tempdb. And guess what? That actually takes space. And there's allocations that happen on pages inside Tempdb to handle those sorts. It's important to be paying attention whether you need to sort objects or you don't need to sort objects because you're using resources inside Tempdb. Now, version stores. What's a version store? Version stores are actually when we keep a version of each one of the transactions or records that actually get changed in your system, and you keep them in a version for being able to be read within the Tempdb file, right? So let's say you have RCSI, read committed snapshot isolation, turned on. That actually uses version stores. It's a really great feature that's actually set as default inside Azure SQL DB. It's a great way to reduce blocking. Readers can't block writers and writers can't block readers. Well, why does that happen? Because you begin to read from the version store rather than the table itself. Well, all of that data is held with inside Tempdb. And if you have long running queries or such with inside your version store, you could get a Tempdb bloat scenario happening. So it's important to know what's going on in your version store, and I'll give you some queries and some DMVs to look at for that. But just keep in mind, if you plan on turning on options such as read committed snapshot isolation, make sure your Tempdb is properly sized for that additional rows and that additional data that's going to be housed there. Just keep that in the back of your mind that that is done inside Tempdb. Now let's talk about configuration. The way you set up Tempdb is important. It is one of the first things that you should set up properly inside your environment. It's so important that part of the 2019 configuration setup, it walks you through and has you properly set up your Tempdb files. Given multiple files for your Tempdb, multiple data files, it's so important that they've now added it inside the installation. But if you look inside your Tempdb and you go to properties here, I want to make sure you have multiple data files, one per each CPU core that you have in your system. Now it says up to 8. 8 is kind of the magic number when it comes to cost benefit. You don't want too much overhead by having too many files. There are some edge cases where you need more than 8 files, but for the majority of us, 8 files is going to be the sweet spot. So I want you to set up multiple files, and you'll see in this example, I have 4 data files. You'll also notice that those 4 data files are all sized exactly the same, as well as our auto growth being exactly the same. Now, why is that important? That's important because SQL Server manages Tempdb in a round-robin fashion. It's going to spread our workload into all of those files, and it's going to look for where the most available space is, and it's going to do the transaction within that space. So it's important to have them all sized exactly the same so they all have the same available space so that it can be used. Now, what happens if I have my very first file is set as 100 gigs, it grew to 100 gigs, and the rest of my files are sitting there at 25 gigs? Guess what's going to happen? I'm going to introduce contention into my Tempdb environment. The contention is because all of the things that need to use Tempdb is now going to go into that number one file. The number one file has the most space. So all of those transactions are going to go there, and the other three files are going to be ignored. That's not optimizing your environment. How do I get that workload to spread across those multiple files is making sure they're all the same size. And when I have a growth event, they all grow at the same time and they all stay in a line. If you go into your system when you get back to work and you notice that one of your files are bigger than the others, you need to fix that. You need to make sure they're all sized the same because you have contention in your system, whether you realize that or not. So properly setting your growth size, and you want to make sure you're growing at a value that makes sense for your data, right? If all of your drives are set at 100 gigs and you're growing at 8 megs, that's not going to make a lot of sense. You're going to end up with a lot of growth events, and you don't want to do that because every growth event gives you performance overhead, right? So we don't want to have that scenario. So make sure they're properly sized. Make sure you keep them in line. We'll talk about some things you can do in some upcoming slides to make sure that stays that way. It's all about contention. You're trying to reduce the amount of contention and making sure that workload gets spread across the files. Now, if I add another file for any reason, that file will end up being empty, right? So if I have an empty file, guess what's going to happen? All of my transactions are going to try to go to that file because it has the most space. So when you get a chance, it doesn't have to be right away, plan for a restart. And what that's going to do is it's going to make it just a little more in line and help the optimizer and help the engine properly allocate which file it needs to go to. And it'll make it just a little bit more better than if you don't do a restart. You don't have to when you add the file. Just make sure you plan for it and do it on the next time, okay? So Tempdb contention. Everything about Tempdb is about contention. It is making sure when we are rapidly dropping and allocating and getting space on pages that it can do it as fast as possible. So there are three main types of contention that you can run into within Tempdb. And I borrowed this slide from my friend Pam Loud from from Microsoft's Tiger team. She is the resource, the go-to person when it comes to Tempdb. And she clearly lays out the three different types of contention here. So I appreciate that I'm able to use this slide. But you've got object allocation, and that is really just managing the metadata that is determining where the next free space is on those pages. It uses the PFS and the GAM page to decide where the object allocation needs to be. And it's going to fight for latches onto those pages and being able to use that space. So that's an object allocation contention. And you can see that with the page latch weight on database ID 2. If you didn't know, Tempdb's database ID is 2. And that's what you're going to be looking for. When you see those weights, you'll see PFS pages and GAM pages. Now, I'm not going to go into what these acronyms mean and how all of this works behind the scenes. Pam does an amazing job for that. And this is just a 100, 200 level. So for time's sake, we're not going to dig into that right now. But just know that's how you can identify that. Then you have metadata contentions. System objects actually have some contention that can possibly happen in the back as it's trying to manage all of the stuff that's coming through Tempdb and keeping track of all of those things. And that actually can create contention in and of itself. There's some fixes and some issues that happened in previous versions of SQL Server that we'll talk about just a little bit that has to do with metadata contention. And just know when it comes to that, it's a lot of the system objects that are tracking the information inside Tempdb that can cause an issue for us. The last one is temp table caching contention. That has to do with memory object and caching that has to go with Tempdb. And you'll usually see that with the particular weight types that I have listed here, the SOS cache store spin locks. I'm not going to go into all of these weights. Just know, and I'm not deep diving into the temp table cache contention. Just know that there are three types of them. And contention is the big thing within inside Tempdb that we're going to try to get around by properly setting it up and making sure our configuration is correct. Now let's look at the main one that I like to talk about, which is the object allocation contention, because we're creating these temp files and these temporary objects and these table variables all in here, and it has to manage and figure out what space is available and how to keep all of these in track and in sync and allocate all the objects properly within inside Tempdb. You have the special pages that happen. Like I said, you had the SGAM, the PFS, and the GAM pages. And it has to figure out with those where to put the transaction, right? Where to write the data, where to do the work. And all of that has to happen really, really fast. And that's when you get into a contention, because they have to lock these objects and they have to lock these special pages and fight for that space. And it can queue things up and it can backlog your temp objects that you need to use and create or drop or whatever needs to happen. And that's kind of where you end up with your bottleneck, your slowdown. It's when it's trying to figure out how to allocate those space and drop the objects and everything and what pages to do that on. So that's just what object allocation is. Again, think of those with your table variables and your temp tables and your temp indexes and all of those things that happen. They're fighting for the space on the pages and where to put that information. So fixing contention. The big thing here, and this is what I just tried to explain, is it's not about I/O, right? It's not about the throughput I/O with inside Tempdb. You want it to be as fast as possible because you want the contention and the allocation to happen and the metadata to be written as fast as possible. And that's what you're fighting over, okay? And to do that, here's a couple hints that you need to do to try to make things faster. And I do have Pam's blog here that I highly recommend you go take a look and reference. But if you're in prior to 2016, there were 2 trace flags that you needed to pay attention to. After 2016, this all behavior is defaulted, so you don't need to worry about it. They handle it for you. But 1118 has to do with mixed extents and how it actually writes and gets to the data. And then 1117 has to do with your auto growth events, right? That's a big one. These are on a instance level, server level, server level trace flags. The trace flags actually say, hey, when I have an auto growth event and I have multiple files, all of my files need to grow at the same time. That way they stay in sync in size, okay? So you want to make sure that happens with Tempdb to reduce what? Contention. So 1117 and 1118 paired together is going to help you maintain that. Now I need to remind you that this is done on an instance level. So if you have user databases that have multiple file groups, those file groups too will all grow at the same time. If one of those actually grows, the next one is. So it's important to make sure your disk allocation is done properly and you have proper sizing to be able to manage and maintain those growth events because they will all grow at the same time. Now, remember I talked about metadata contention, right? Metadata is outside of the scope of us DBAs, right? That's the system objects and everything that's tracking all of the things that are being created and deallocated all throughout Tempdb. Now, there was actually contention that was happening in the background that was causing problems with inside Tempdb that has been fixed by just applying the latest CUs. So for 2016, make sure you're on CU 8 or above, and on 2017, make sure it's CU 5 or above. You had a bottleneck with inside Tempdb that you may not even be aware of, but being on the latest and greatest patching fixes a lot of bug fixes. And in this case, it happened to occur with inside Tempdb. So make sure you're on the proper things. Using table variables versus temp tables, that also makes a difference for contention. And we're going to touch on each one of those in just a minute. So deciding which one to use and which one is best and how they actually work is important. So don't just randomly pick one. There is a logic to how you do it. There's also inline index creation that happened with 2014 that actually makes a difference in contention. So if you're doing temporary index creation, definitely look at the inline syntax for that. So table variables. This is what I affectionately call an @ table, right? That's how I learned table variables is an @ table. So the rule of thumb for this is if you have a row count that you're expected is less than 100, use a table variable. Why? Because there's no statistics associated with it. There's nothing to give the optimizer the actual row counts and what to expect and the selectivity actually of the data. So it doesn't actually help you when you go to a greater number of rows when it comes to performance, right? So rule of thumb, if you have a small row count, now we all know that changes over time with the amount of data in your tables, but rule of thumb, try to keep that usage with smaller table result sets. Now there is a trace flag 2453 for table variables. We're going to dig into this a little more and you'll see a demo, but table variables in the olden days, previous versions to 2019, and we'll talk about those options later, but previous versions to 2019, table variables actually created an issue for us, which is why we go with less than 100 rows. It actually shows us an estimated row count of 1. So no matter what our actual rows coming through, it always planned for the resources for one record, which means we usually spilled to Tempdb or we didn't get the proper memory grants, or we didn't get the proper joins, things like that that are actually determined by the optimizer with the row counts. So in order for a table variable to use actual rows counts, turning on 2453 enables and triggers a recompile. When it does that, it can actually use the actual rows to determine the resources for each one of the operations and all of the subsequent operations that happen within inside a query execution plan. So if you're using table variables at all, there is not a downfall to this. Turn on trace flag 2453 and you're going to get a much better, did I say much? Yes, a much better execution plan for every single query that uses a table variable. Make sure you're turning that on. Now, let's talk about pound tables or temp tables or global temp tables. If it's got 2 pound signs, then that's actually a global table. It can be used by all statements that are reading from that global table. The temp table, singular one, is within inside that session, right? So there's a couple things that we've been taught along the way when we've been coding is that we should always look and see if a temp table exists, and then we should drop it at the end of our store procedures. Well, we actually don't need to do that anymore. That's unnecessary. The engine handles that for us in a much more efficient way than us actually taking the time to check and see if a table pre-exists or not. Okay, we want to make sure we let the system do that. So take that out of your code. It's not necessary any longer. Don't alter your temp tables. Once you write and create your temp table and then you populate it, don't go back and retouch it, because what you're doing is you're invalidating the cache, right? If I touch it once, if I create it, input the data, and I do that all at once, or I create the table and then I insert the data, then I'm creating something that lets me actually use cache. I get reuse of that, and I'm not actually creating and dropping objects and replacing that object because I've made a modification, such as adding an index to that temp table. Do it all at once. Create the object, do the inline index creation, and then populate it. And then I'll be able to cache that. Contention inside Tempdb, again, is about allocating objects, right? Some of that is allocating objects. Anytime you touch your temp table inside your store procedure and you make some kind of change to it, it invalidates it and it has to create a new object, and you lose that ability to use it in cache. The more temp tables that are created and deleted, the more likely it is that you're going to have a contention scenario inside your environment. So things to take away from this is let the system do the cleanup for you. Don't write that if exists statement, and don't write that drop temp table at the end of your procs. Let the system handle that for you. It does that in cleanup, and you don't need to incur that extra overhead. So in 2019, they've given us some real great improvements, and I'm really happy they're spending time on this. Temp table caching, they had some improvements, and because of time, I'm not touching that subject here. Pam does a good job of talking about that in her sessions. I recommend you again check that out. They handled some concurrency inside the PFS pages. They've done some updates on that. There's a lot of information. You can go check that out. Memory optimization inside Tempdb, the metadata, they've done some really great things on that and try to improve the performance on the metadata side. That makes this stuff go faster for us behind the scenes. And then my favorite thing they added, which is what I'm going to go through here in a second, and we're going to demo and see, is they've handled that estimated count of 1 for us by introducing the table variable deferred compilation. And I'm really excited to show that to you because they've fixed it without us having to use that trace flag. So let's see exactly what it does. Knowing exactly what the actual counts are really improves our plan quality, right? It allocates the proper memory grants and it makes the right join choices for us just by knowing the actual counts. So what this does is it allows the cardinality estimator to compile and get the actual counts as it moves along within inside our execution plan, which gives us really accurate, better choices from the optimizer as it moves along our plan and gets the result sets that we want. We remove the possible spills to Tempdb and the not preferred join types, as well as some other things, just by actually having this. It is defaulted and turned on by 2019. There's nothing that you have to do to enable this. You just have to be on the right compatibility mode, and all of a sudden you get this performance enhancement. Now, if you're not on 2019, and I touched briefly on this with the table variable page that we talked about, we could fix this, right? We could avoid the estimated row count of 1 by turning on that 2453 or using an option recompile within our code or giving specific plan hints for that. Or we could have skipped table variables altogether and just did temp tables with inside our code. And I've seen that too. But you can see from this picture, if you're not familiar that this is actually happening, is that when I'm using a table variable, look at that estimated number of rows read. It says 1, right? But if I look at the actual number of rows, it was 116,000. That means my memory grant was not given large enough for the value of the number of rows to come through. It actually just gave me a little bit of memory expecting to handle 1 row. So all other choices were made based on 1 row. If I had these other options turned on, I could get it to actually allocate correctly for the 116 rows. And I'm going to show you that in a really great graphic that I took from Microsoft that really explains all of this for us. And then we'll walk through that demo. So let's take a look at this. Here you can see that in my number 1, I've got a clustered index scan, right? If I highlight it over that, I right click and I go to properties, I can see my estimated rows were 1. It actually used a table variable and I've got that what I expected, 1 row. But look at my actual numbers. My actual rows were 77,000. So when it did my memory grant, it only gave me a small fraction of memory and it's what it needed to be able to handle 1 row, but I have 77,000 rows. So because it only expected 1 row, it decided on the next phase, because that 1 row kind of follows throughout this whole thing, it decided to go ahead and give me a nested loop as my join. Well, if I had more rows expected to come through, it might have made a different join choice, which could have given me a more efficient plan and a faster response time, right? Better performance. But that 1 row is going to travel from that number 1, number 2, number 3, number 4 option and operators that are inside my execution plan. And all decisions made by the optimizer is done through that. If I look at number 5, you can see I have a sort. What did I tell you in the beginning? I let you know that sorts happen with inside Tempdb. Well, if I actually were to hover over and see what that exclamation point was telling me, it's going to say spill to Tempdb, which means if my disk is my bottleneck and I have really really high latency on my disk, then I'm just introducing a bottleneck into my query here, right? I don't want to spill to Tempdb. I don't want to have to go to Tempdb to manage my workload to do that extra work, which puts me on disk, which could be my bottleneck in my entire environment, right? I want to stay away from disk. So I want to make sure my memory is allocated enough to handle the workload, those 77,000 records, and not have to do a spill to my Tempdb and use those resources. Let's see how the new table variable deferred compilation fixes that for us. So here is the exact same query. Look at this. Number 1, I no longer have I have my scan, and if I go and hover over that, I no longer have an estimated rows of 1. Look at that. It actually did a compile and decided to grab the actual number of rows, which is 77,000 here. They match. It's never not going to match. It matches. It's going to take those actual numbers. So look at our number 2 step, right? We have 77,000 rows now rather than 1. The optimizer decided a hash match is going to be much better than the nested join. So I've already gotten a benefit by using a better join type and getting the proper memory allocation to make those determinations by the optimizer here. I've got my sort, right? The grant now has enough space in there for me to do my sort, and I don't have to go to Tempdb. You'll notice that the explanation point is no longer there. And then I move on to my parallelism in my select statement, and bam, I'm done. It is much faster. I've got a better join type. It knows how many records to get. And I'm now no longer spilling to Tempdb or using any of that space that can be used elsewhere. It's really great. And again, this is an option that comes with 2019 that you do not have to enable. It comes in by default. So let's talk about space inside Tempdb. It's important as a DBA to know what is actually using the space inside Tempdb in case of a time that it's filling up Tempdb, or I need to do some optimizing inside my queries and finding out exactly how much space it's using inside Tempdb. I can get all of that information in these DMVs that I have listed here. You've got space usage is the very first one. It's going to give you the space within each one of your files. Then we have session space used. That's all the sessions that are currently running and how many pages are allocated or being deallocated by each one of the sessions. And then we have each task. Each task is going to tell us how much that task here, the task space usage, is being used, deallocated and reallocated. Now, the session space and the task space are both only existing inside Tempdb. These are special DMVs for Tempdb. The file usage one, you can look at that for your other user databases as well. But it's all about allocation and deallocation and how much space each one of the transactions are actually using. Now, remember I told you with snapshot isolation, read committed snapshot isolation, it uses version stores. Well, version stores, as we learned, are held inside Tempdb. Now, RCSI is even the default of Azure SQL DB. It's really important to be able to alleviate blocking by using this version store. So no longer our selects are blocking our updates, inserts, and deletes. We're able to bypass that because it reads from the version stores. It's the allow snapshot isolation equal to on and the read committed snapshot isolation equal to on a database level. Now we need to find out what exactly is being held in our version store, how much space is being consumed by our version store. We have 2 DMVs to be able to look into that, and I have those listed for you here. Now, spacing and size consumption usage of Tempdb is a big part of it, right? So we need to find out what is filling up Tempdb. If we've ever been in a scenario where Tempdb just exploded and we ran out of space, and we need to figure out what long-running transaction or what queries are consuming all of our Tempdb, we can do that. Kendra Little gives us a really great query that I show the results set here with. And it will actually show you all the statements that are running in the system right now, give you a query plan if there's one available, and tell you how many row counts and what exactly it's allocated with inside Tempdb here. You can easily identify those transactions, and I highly recommend you downloading her script in order to check that out. Now, resizing Tempdb. In an emergency situation, we've always gone and said, we've run out of space on our disk drive, things have been filled up, and it's Tempdb. We're completely out of space. We saw the error message, and we're now in an emergency situation where we need to get space back with inside Tempdb to actually be able to use our system because production is down because Tempdb ran out of space. And remember, Tempdb is a global resource and everybody's trying to use it. So a quick fix to this, which we usually can't do in a production environment, is to just restart your SQL services. Remember, I told you Tempdb gets recreated upon restart of your SQL service. And that means you're going to get brand new files at their original file size and nothing will be using it. And you're going to restart and you'll be off and running. But that is a downtime scenario where you do have to restart. So that's something you don't necessarily want to do, but it is a quick fix. Another thing I can do, say I've run out of complete disk space on my T drive. I'm not sure what I can do to shrink that database yet. So I can add an additional file and have that additional file placed on another drive, which will give me space and get me off and running. Now, I like to think about that as just giving me some breathing room. It's a temporary fix. I need to make sure I go back and I properly size my Tempdb files and I put them all in the same drive. And I fix that when I'm able to do a restart of my services. You don't want to have that extra file hanging out on another drive and being a different size than anybody else. So make sure if you're in an emergency scenario and you add that additional file that you later go back and realign everything and get everybody on the same disk drive when you're able to do a restart and set things back up. But it is an emergency solution. Now, the last one is shrinking the files. And that's a pretty easy thing to do, but some of us run into a problem, and I'm about to walk through that problem with you. Now, I created this diagram basically for me because I wish it was something that I had when I was in the scenario of my Tempdb was too large. I ran out of disk space, and guess what? It wouldn't shrink. I wish I had this checklist, so I took the time to actually draw it out and put it out on my website that you can download as a walkthrough checklist if this actually happens to you. But when you need to shrink Tempdb, sometimes there are things that are holding on and latching to those resources, and it won't allow you to shrink the file. No matter how many times you run dbcc shrink file to resize it, you're still stuck and you can't get that space back. So this is what you need to do. The first thing we're going to talk about is issuing a checkpoint. You always have to issue a checkpoint. And that just tells the engine from this point, this marking in this file, I'm good. Anything else after that, you can start applying changes and reusing. But prior to, I've marked the checkpoint. We're at a good starting point. So I'm going to run a checkpoint. The word is just checkpoint. You execute it. And then I'm going to run my dbcc shrink file. Now, what's going to happen for, I'd say 75% of you guys, is that it's going to shrink the file. You're going to get it right to the size that you want it to be, and you're off and running, and your Tempdb is working, and your production environment is back up. That's what you want to happen. But for some of us, that doesn't work. Some of us, we have a little more work to do in order to get our files to shrink back down. But before I talk about the next options, I really need to give you guys a warning, and I need you to pay attention, which is why I have it up on this slide. The rest of the options I'm going to talk about and actions you need to take in order to shrink the file will flush your cache. It's going to flush your buffers. It's going to flush your cache. It's going to flush your system cache. It's going to flush a lot of things, which means you're going to incur a performance hit. The performance hit is going to be after you run these things. As we're clearing out all of our cache and all the stuff that we like to reuse all the time, we've got to warm our cache back up. We've got to get all that information back into cache for reuse for things to go faster. So after we've run all of these things, we have to give it time to repopulate our cache. That's where you incur your performance hit. It's the repopulating of cache so we can get that reuse going again. So don't worry about if you get a little bit of a slowdown after you get your Tempdb shrunk after running all of these. It will go back to normal. It's just warming up your cache. But that also means you don't want to do this if you don't have to. You want to try to look at my diagram, and every time I ask you whether you shrinks or not, then determine whether you need to run the next options. Don't just run them all thinking you have to run all of them to make it happen. Let's pause at each step and see if you're able to shrink, okay? So I've run my checkpoint, I've run my shrink, and it didn't work. I'm still have all of my space allocated and I'm still down. The next thing I want to do is drop clean buffers and free my procedure cache. This should actually take away some of the things that are hanging on to Tempdb. It's going to flush my cached indexes, some data pages that are out there, the procs that are out in procedure cache, all of the stuff that could actually still be attached and holding on to Tempdb, it's going to drop. After I run those two, and you do have to run both of them, I find, I'm going to run that dbcc shrink file and see if that works. Maybe I add in another checkpoint and then run dbcc shrink file. Now that's going to get 95% of us. After that, you should have been able to shrink your file down to what you need it to be. I'm pretty sure it's going to handle at least 95% of you, maybe 97, right? But there's going to be a few of us that are still sitting there pulling our hair out, trying to get Tempdb space back so we can continue on. For those that haven't been able to accomplish the shrink yet, go ahead and run free session cache and free system cache. That's going to get the last bit that is hanging onto your Tempdb to let go. Okay, any objects that are still holding on will get dropped, and you should be able to shrink the file. Once you do that, you'll be off and running. But again, if I'm giving you two things, it usually means both of those things have to be done for you to get your shrink file. But this should handle, I would say, 99.999% of the people that can't get your Tempdb to shrink. If for some reason you're still hanging on after all of this, I think all you can do at that point would be to restart your services. But this is going to handle most of you guys' issues. So let's talk about spill to Tempdb. I've talked about this word earlier, and we saw it in kind of that exclamation point for that screenshot. We were looking at that spill. But what that actually is, it means, like I said, it did not give you enough memory because it did not have the right amount of rows in your estimated rows. Now, we talked about that for table variables, but spills can happen on any query that comes through where you get a low estimation and it does not match your actual counts because it did not allocate enough memory to handle that workload. Again, it goes beyond table variables. This can happen in any query that you might run. You'll see this warning spilled to Tempdb, and you'll see level 1, 2, 3, 4, 5. I'm not really concerned about the levels. When I look at a level, I might Google and see what it is. But right now, spilled to Tempdb, just know that means it had to go to disk. It had to go to Tempdb to handle the workload. And you are now in a scenario where you need to fix something to make sure you get better performance. And what that has here, it all has to do again with those memory grants, right? It needs to give you enough memory to handle the row counts coming through. And in this case, you can see that underestimation happened. I've got an estimated row of, it says 1, right? Estimated row of 1, and then my actual rows were 15,000. Well, what happens when you have that over under between, or those gaps between the estimated and actual, is that I didn't get the right memory. How do I fix it? It's really, really simple. If you guys go back to the basics, you know that estimated rows and actual rows are determined by your statistics. Your statistics tells the operator what to expect, right? What's the selectivity of the data coming through? What rows should I expect as far as counts? The closer those two numbers are, the better the resource allocation that's going to happen with that memory grant. So if you see big giant gaps between your actual and your estimated, make sure you're updating your statistics and you're doing statistics maintenance at a regular basis to make sure those numbers are aligned and you don't get into the spill Tempdb fiasco. So if you see a spill, double check your estimated versus row, update your statistics, and it should fix the problem. Now, what they gave us in 2017, which made me really happy, is they have this thing called memory grant feedback. And what the system does now is it watches for spills to Tempdb, and it kind of creates a table in the background where it is monitoring these events that are happening. And if it keeps happening over and over again, it adaptively fixes the workload for us. It addresses those workloads that are happening multiple times and getting the incorrect memory allocations. It's called memory grant feedback. And what it's going to do is, as the queries come through again multiple times, it will adjust the amount of memory that's happening and actually give you the proper allocations and gets rid of the spills for you. Now, memory grant feedback is on by default after 2017. It's not something that you have to turn on. You'll start to see these things resolve itself. And there's actually a place where you can look to see how it's tracking all of this. And I can't think of it offhand. I think there's a spill report to memory grant feedback extended event that you can look at to find the information, but I don't have it in my notes here. But there's ways to track this within inside the system is my point. But it's really great. It tries to help Tempdb out by doing the proper allocations here. Now, the last thing I'm going to talk about before we get into the demo is always-on availability groups actually use Tempdb. And this is going to apply to your read-only replicas. The read-only replicas actually read from version stores. They use snapshot isolation. And those version stores, like I said, is something that you should be monitoring. The version stores can fill up really easily too when it comes to long-running transactions that happen on your read-only replicas. So if you find if your Tempdb is filling up and you really don't know what the cause is, it is possible that your AGs are playing a part in there. So I just wanted to quickly mention that. I do have a resource for you when it comes to availability groups and how it's used within inside Tempdb that I'm going to give you at the end of this session. So just make note of it. I also want to let you know that the secondaries don't actually have their own statistics. What happens is in Tempdb, it creates a temporary statistic on the primary that's being used by the secondary read-only replicas. Those duplicate statistics, these temporary statistics, are fed over to the secondary replica, and I just want to let you guys know that it uses Tempdb for this. So just note that in the back of your mind that the availability groups has to do with the statistics and the version stores when it comes to Tempdb. Now let's dive into a demo and let me show you what those 2017 memory grant feedback and the 2019 deferred table variable deferred compilation actually does in the system, which is really cool. Okay, so it's time for the demo. We're going to demo first table variable deferred compilation. It's still so hard to say. And we're going to create a store procedure and a table variable, and we're going to do some selects from it, and we're going to see how it gives us the estimated counts will now show us the actual row counts instead of that estimated of 1. So let's start out first. We always want to make sure we're on the proper database. So here I'm on Worldwide Importers. It is a sample database from Microsoft that you can download and follow along with. We're going to create, and I love the create alter now. Create alter, we're going to make a store procedure, and we are going to just create a table variable, insert some information, which I'm grabbing from the sales invoice lines, and then we're just going to do a select from that table variable. Very, very Easy to do. I'm going to run that and we're going to execute it. Now, to actually demo this, I'm going to lower the compatibility level to 130 so we can see that spill to Tempdb, and I can show you what it does. I'm going to just go ahead and alter the database, setting it down to 130 versus 150, and we're going to execute that. Now I'm simply going to be using my worldwide importers at the 130 level, and I'm going to execute the store procedure that we just had. But before I do that, I want to go ahead and make sure I do have my actual execution plan here so you guys can see it. So let's go ahead and we're going to use worldwide importers here, and we're going to execute that. And we will sit here and look at our execution plan as it comes up. Now, if I go and hover over here, guess what I have? Over the clustered index scan, look at that. That estimated rows was 1. And look at our actual rows. You can see it there at 228,000. So it gave me a memory grant based on 1 row as we expected, right? Because it's a table variable. And it really pushed through 228,000. And we can see we got a nested loop. And then we have our sort. Guess what? Here we go. We got a spill to Tempdb, right? We have an exclamation point. I hovered over it. There's my spill to Tempdb because it did not know that it was expecting 228,000 rows to come through. It expected 1. So I got 2 problems. I've got a nested loop that was actually used when maybe something else could have been used because I brought in 228,000 rows. I needed to sort it and it couldn't sort it in memory because of the memory grant, and it spilled to Tempdb to actually make that happen. Now let's go back up and let's go back to the 2019 150 compatibility mode. Now I said in order to take advantage of this table value deferred compilation, I don't have to do anything except for be on the 2019 version of SQL Server. Watch what happens. I'm going to go back to worldwide importers and I'm going to run it once. The same thing, and look, if I go over this, I've got estimated rows to be read. Guess what? 228,000. Look at that. It actually, instead of using 1, it made a determination based on the actual rows, and I get proper allocation. And look, I've got a hash match that actually happened, and I've got an adaptive join, which is another 2019 great feature that we're not going to go into. But look, it changed, not only gave me the proper amount of rows to expect, but it made better decisions, right? I've got a better join, and look at my sort. My sort is no longer spilling to Tempdb. It did all of that work and did not have to go to disk. So it's something really great that 2019 gave us, where we didn't have to make any adjustments in our code to take advantage of it, and all is happy. That means also, because I'm on 2019, I no longer have to have trace flag 2453 enabled or using option recompile within inside my procs as a hint. All right, let's dive into our second demo. This is memory grant feedback. And remember, memory grant feedback is going to actually fix our issues when statistics actually gives us the estimated versus actual way off. So therefore, our memory grant that was given ended up being improper, and I spilled to Tempdb. So what memory grant feedback does, remember on subsequent runs, it will note these spilled to Tempdbs and then change the memory allocation to prevent us from having to go to disk. So let's take a look. This is an option that you don't have to have any code changes for, and the only thing you have to make sure you're on is the proper version of SQL Server, which was 2017 or above. And so I'm going to demo this, changing my compatibility to 140, which is 2017, because as we remember a minute ago, I'm on a 2019 version. So I am actually using Worldwide Importers DW, the data warehouse version, that again is a sample database from Microsoft. And I'm going to go ahead and clear my cache because I've been testing this and I want to make sure you get the proper results. And we're going to change that compatibility level. Now I'm actually just creating a store procedure that we're going to run to be able to show this. And I do have my actual execution plan on here so we can actually see the differences. We're going to go ahead and execute this. Now I'm in 140. I'm going to go ahead and run this particular one with a row count of 0. Just so it can actually get here, there was an excessive memory grant. We're going to see that actually change. And I'm going to run this one. Now, what this one's going to do is it's going to run it and return some rows. It will adaptively change that memory grant so I don't get this memory warning because there's a memory grant warning associated with it, it's going to go away. When I actually run this, we will see it's got data in here now, right? The last one didn't have data. We're going to see here, guess what? We've got a spilled Tempdb, right? Because the first time we ran it, it only had one row. The next time we run it, we brought in a bunch of data, right? So it's the secondary run. And now we have a memory grant that wasn't necessarily sufficient. And we did a spill to Tempdb, right? I've got a spill to my sort. We've got spills going all over. But guess what? It knows it's spilled. It's marked it in the table in the background. If I keep rerunning this, it's going to go away and adaptively make the changes. Let's take a look. Guess what? Look at that. I didn't make any changes. All I did was rerun the statement. And it knows in the background that did it spill last time? It wants to go and adjust its grant. And look, it's gone. It's very cool. So in the background, the engine and the people designing the engine has decided to solve some of these really common issues that we have that affect Tempdb the most. It's going to be the table variable deferred compilation, and this memory grant feedback is really going to help free up some of those Tempdb resources and prevent us from having to spill to Tempdb. So I hope you enjoyed those demos. They're really cool. I'm very glad they've actually gone this direction. Let's dive back into the presentation. So here is the reference slide I want to give everybody. I've got the notation to go check out Pam's blogs and her videos out there on Tempdb if you really want to deep dive into it. She does a fantastic job really digging into the contention portion. So I highly recommend you go take a look. Then I'm giving you Kendra Little's script. There's the link again for you to dive into what's actually using Tempdb. It's very, very handy. For those checking out the Always On Availability group, I have the Always On script here for you to check out. Of course, Microsoft's Tempdb script, so you can read a little bit more of that. And if you're a true nerd and you really want your head to explode, I recommend going to look at Bob Ward's internal session on Tempdb. It's about 3 hours long, but he's going to really dive into the page cracker, and he's going to get into things and show you those actual contention scenarios that happen on the page and where it's writing and finding that information. Your mind is going to hurt. It's going to explode, but it really is a great deep dive into the internals of Tempdb. It's 3 hours long. Take it in chunks. Expect your brain to hurt, but I highly recommend it. So thank you so much for joining the session. I truly appreciate it. I hope it gave you a good foundation and get you questioning how Tempdb is actually being used and some resources on how to look and see what's consuming your Tempdb. Again, reach out to me on LinkedIn or Twitter if you have any questions whatsoever at SQL Espresso. Thanks again for joining me, and I hope you enjoyed the session.